Welcome back, K-State aviation students. I'm your instructor, Tom Mahoney. This will be the fourth lecture that I provide on advanced aircraft systems. We will be talking about air conditioning today on the CRJ 700. Let's jump right in and get started. Okay, now that I'm set up, again, it'll be the air conditioning system, how it operates on the CRJ 700. The air conditioning is a subsystem of the pneumatic system. Without the pneumatic system, the air conditioning system on these commercial jets is not going to work. They don't work on electrical. They don't work on gasoline or fuel or jet fuel. They work on pneumatic air. So without having pneumatic air, you have nothing you can do for air conditioning. And for that matter, you can't get pressurization accomplished on the aircraft either. So in flight, pneumatic air is normally supplied by either or both of the main engines. On the ground, it is normally provided by the APU bleed air or bleed air coming from either or both of the main engines. There are some cases where I suppose you could power up the pneumatics using high pressure external air, but in 20 years of aviation experience in the commercial airline business, I have never seen that ever happen. So on the ground by the APU or either or both of the main engines, in flight normally by either or both of the main engines. Let's just take a little closer look here, what we're talking about. In this case, looks to me like the engines are in flight or the aircraft is in flight. The engines are operating. It could be on the ground. That does work for me also. The engines are providing bleed air pressure. In this case, it looks like bleed air pressure being provided by the 6-stage compressor section. It is not being provided by the 10th stage because the high pressure valve is closed. Likewise, on the right engine, same scenario. So in this case, it looks like 6-stage bleed air is providing enough pressure to power up the packs. And in this schematic, the right engine is showing powering the right pack, and the left engine is showing that it's powering the left pack. This is the left pack valve. This is the right pack valve. They are showing open. So we have the pack sitting up in this location here, in the schematic anyway. And with that happening, we are able to provide pack pressure, bleed pressure to the packs in both cases, left and right. Okay, moving on now. We are going to get the big picture of how the air conditioning system works. This is kind of the picture I've always had in my head when I'm operating these systems. I don't try to go into the very minor details of exactly how the pack works. I know that the pack produces, takes in hot air and kicks out cold air, and then we modulate that cold air with more warm bleed air to eventually get ourselves the right temperature. That's really all I need to know about how the pack operates, but we will go into more detail in following slides here. But for now, I want you to get the big picture. The air conditioning system is made up of 2 packs, AC kits, pneumatic air conditioning kit packs. That's it. That's the last time you're going to hear me say that. Both packs operate using hot air supplied by the main pneumatic cross ducting, as we saw on the previous slide. As air is circulated through each pack, being compressed and then expanded, this process cools the air and then sends it on to the mixing manifold. The mixing manifold redirects the conditioned air to the flight deck and to the passenger cabin. As the air passes in and into and through the pressurized area of the cabin or the fuselage, it is normally recirculated back to the mixing manifold and or exits the aircraft through the pressure outflow valve. So what are we talking about exactly? Let's dive into it here a little bit. All right, we talked about having this cross duct down here along the bottom, and it's providing pressure. Of course, the isolation valve is in between, probably closed in this scenario, providing pressure to the left pack, and the right engine is providing pressure to the right pack. The left and right pack cool the air down, so as it comes out, in the left pack case, the cool air travels upward to the mixing manifold, and the left pack, generally, that air is going to be in this section of the mixing manifold. If we're talking about the right pack, its cool air travels upward into the more aft portion of the mixing manifold. And at any rate, the mixing manifold then redirects the air, in this case, to the passenger cabin and into the cockpit. So think of it this way. We've got the left pack coming up, dumping air into the mixing manifold. Most of that air coming from the left pack will end up coming through this ductwork right here into the cockpit, and of course, some of it ends up in the passenger cabin, and most of the passenger cabin conditioned air traveling from the right pack comes up through the manifold and then is redirected to the passenger cabin. So in simple terms, the left pack provides conditioned air to the cockpit, right pack controls conditioned air to the passenger cabin, except the reality of it is it does get mixed somewhat in the mixing manifold. So you could say a little bit of the right goes to the cockpit, but generally most of it is left pack air. Once it goes into the cabin passenger or the cockpit, the air gets returned out of those locations up through this ductwork via the recirculation fan here. So this recirculation fan is turned on. It sucks air out of the passenger cabin and the cockpit, in this case, brings it back into the mixing manifold. And this is a check valve, so it's a one-way, it can only go one way. And also, we have another recirc fan towards the aft of the passenger cabin, sucks the air out, brings it back into the mixing manifold. So you probably heard on the news that this air changes out in these airliners. It takes, 2.5 minutes and the air is all changed out. We have new fresh air. I don't know if I'd actually go along with that, because the reality is that this is in this airplane, this area here is your pressure vessel. Actually, this whole thing is a pressure vessel. It includes the aft cargo bay. And back here on the bulkhead is an outflow valve. Now, that outflow valve, when you're at altitude, cruising along at 34,000 feet, is generally closed to help maintain the pressure in the pressure vessel. If that valve opens, it's going to dump pressure out, so we're going to lose pressurization to some extent. Now, this does modulate open and close depending on trying to control the pressure in the cabin. I believe it's at about 8.2 psi while you're at cruising altitude. Nonetheless, the air just doesn't travel willy-nilly out of that outflow valve because it's mostly closed at altitude. And what you're relying on is recirculation of this air going back to the mixing manifold and being reintroduced in the cabin. So if you're sitting in the back of the airplane and you've got a big head cold, somebody sitting in the center of the airplane, that person in the center airplane could get your head cold because of the recirculation of the air. So if it's cold season, I don't think it's a bad idea to wear a mask when you get on the airplane. Make sure it's one of those in-one masks so it really filters out germs and other bacteria from other people. But this is a fairly confined area, so it's a breeding ground for colds and other things that can be passed from one person to another. I don't care what the news says. I think they're absolutely wrong if they say the airflow goes out and you're safe sitting in the airplane from getting somebody else's cold. I don't think that's actually true. Now, the other part of this system that you might want to take a look at is uh, as the air is recirculated back uh, to the mixing manifold, there's another duct here that brings air, conditioned air, back to the cargo compartment. So if you had live animals back here, you'd not want them to freeze to death. So you would open the cargo air valve, and that would let warm air go into the cargo air. One of the things we used to call these kind of cargo compartments in the major airlines and the big airplanes uh, is the puppy snuffer. So if you didn't keep that thing warmed up enough at altitude, it can get really cold and your live animals can freeze to death. So in this case, we would always make sure we had this cargo valve uh, open so we could get warm air back there to any live animals. Very important. If you don't do that, the airline's going to be looking at a lawsuit when somebody's little poodle out there shows up stiff as a board when they take it back out. So make sure you're keeping your live animals warm. It's one of the reasons I believe Southwest always allows passengers to carry their pets in the cargo bay or in the passenger cabin, so that we don't have a problem with having to pay for lawsuit because a pilot was stupid and didn't turn on the cargo air valve. So that's important. Keep that in mind. Don't get your passengers upset. Okay, so that gives you the big picture of how that works. Trying to look at anything else here. Of course, you have your, as with all jets, we know this now, some of this stuff is controlled by computers, and you have your air conditioning system controller number 1, and you have your air conditioning system controller number 2. They regulate and operate the recirc fans and measure the temperature, adjust things automatically. So when you're selecting the temperature for the cockpit, you're actually telling the air conditioning system controller number 1 what temperature you're looking for, and then it's going to start automatically adjusting the temperature. And if you're going to adjust the temperature in the back, you're going to be selecting it on the temperature control knob number 2, and then that controller is going to control that temperature for that part of the aircraft. So that's about it on the big picture. Let's take a little closer look at the details. Continuing on, there are 2 packs left and right. A pneumatic air is provided by each pack by operating the respective pack valve. That's down here. In flight, each pack is normally provided pneumatic bleed air from its associated main engine. We talked about the APU being able to operate up to, or the APU being able to actually operate at the normal cruise altitude, but even though it's operating, we do not use bleed air from the APU in this airplane above 25,000 feet. On the ground, a combination of either both engines or APU bleed air normally provide pneumatic air during taxi or while parked at the gate. Let's take a look at where the packs are located and a little discussion about ram air. The location of the packs can vary widely from one aircraft design to another. On the CRJ700, the packs are actually located in the aft portion of the tail section between the 2 engines. Of course, that's where you'd want them because you're wanting to pump bleed air to them. the shortest distance is right at the engines, right? And as we recall from the APU video, the APU videos, the APU is located right here, and the bleed air for the engines right here. So it's a very short distance to get this bleed air to the packs. That's a good thing because this air is hot. We don't want it just drifting all over the cockpit, wreaking havoc if it were to leak and not be detected. Okay, on the CRJ 700, a ram air inlet is located on the top of the fuselage, just forward of the vertical stabilizer. Ram air is normally used for pre-cooling the air that enters into the packs. When the packs are not operating, ram air can actually be used to help provide fresh air to the cabin. So right there, right where that little yellow arrow is pointed, that's the inlet for the ram air. So as air is passing over the aircraft while in flight, it can be pushed into the ram air inlet. All right, so now let's take a little closer to exactly how the pack works. The left and right pack are identical, so we're only going to show you how one pack works. Once you know how one pack works, then you'll know how they both work. So first of all, hot bleed air enters the pack when the pack valve is open. We talked about the pack valve earlier. That's the valve that's right on top of the cross duct manifold. When that's open, pneumatic the air is pre-cooled. Let's go back. Hot bleed air enters the pack when the pack air valve is open. Waiting for my screen to clear up. Let's go back. So let me just take a look here with this. So that pack air, that pack valve would be right here in this area, and that's allowing the hot air to enter in to the pack. Think of the pack as being in this area, so it makes more sense for you. The pack is like inside this box. All right, that's what the pack is. All this stuff is inside the pack. So hot bleed air enters the pack when the pack valve is open from the pneumatic cross duct and is pre-cooled by ram air. So let's take a look at what's actually going on here. As you can see, the hot air from the bleed air is coming in. Bleed air is really hot. It goes through the primary core, which is nothing more than a heat exchanger. This is our inlet right here for air. Remember the ram air inlet on top of the fuselage just forward of the vertical stabilizer. That's where the air is coming in. It comes on down through this direction, comes on down through here, and then of course is discharged overboard. And this is a pre-cooler. So it cools that hot bleed air down, turns it in from hot to warm air. The warm air enters the compressor side of the air cycle machine. Another term we need to know. This is what we call the air cycle machine. There's a couple little turbines here, turbines and compressors. So warm air enters the compressor side right here. So it's coming across here, coming down, enters this compressor. The air is compressed and then exits and goes through another set of heat exchangers. The warm air circulates through the heat exchangers and in the ram air ducting where it is further cold. So more air is coming down through here and it's getting cooled off again and it comes back out this direction, travels on down as it's shown here in yellow. It cools down a little bit and the air then is ducted through a reheater, a condenser, and water extractor where water is removed and injected into the ram air ducting and to aid in cooling ram air. So let's take a look at what it's doing. coming down this way, going down through basically a reheater, and then it continues on through a condenser, and then it continues on. The air goes through a water extractor. This water is taken out, run back up into the ram air ducting, sprays out inside the ram air ducting, cools the air a little bit more, and that's why the heat exchangers here are more effective, because now the air is even cooler by being moist as it flows over the heat exchangers, thus cooling the air down. The drier air now, this is dry air coming this way, is returned to the turbine side of the air cycle machine. We call it the ACM. And when it gets to the turbine side, the air is expanded. And when it expands, now that air gets even colder. It then comes along and goes out this direction and passes on. And the cold air that exits the air cycle machine is mixed with hot bleed air. We'll get to that in a second. But the air continues on and then goes to the mixing manifold. That would be up here somewhere in this area. Okay, now this is going to be really cold air, because when it expanded coming out of that turbine, it's pretty icy. Now, we don't want to pump that kind of cold air into the cockpit. People would be putting their jackets on and complaining about not having blankets on the airplane. So we try to take care of that problem. Here's how we do it. If you remember back here, we had hot air coming in from the bleed air source, from the engines or the APU. We siphon a little of that hot air off. We bring it down this direction. And then we have a temperature control valve here, which is actually what is controlled by the temperature controller computers. But we set the temperature in the cockpit and tell our temperature controllers how far to open this valve or what temperature we're going to look for. So as that valve opens, hot air now comes forward and is dumped into the cold air exiting the turbine side of the air cycle machine. When that hot air is modulated into this cold air, the cold air now warms up, and we can now control the temperature of the air going to the mixing chamber down the line in the aircraft. So that's how the pack works. Try to work your way through that on your own. And there again, that's how it works. So air comes in here, we'll just draw it, comes in here, pre-cooled, comes into the air cycle machine, is compressed, comes back out as warm air, is cooled off a little more from ram air coming through the ram air inlet, comes back out here as warm, gets cooled down a little bit more, goes through a preheater, then a condenser, water is dropped out, water is separated, the water goes back up into the ram air, is discharged in the ram air ducting, helps cool the preheaters down, or the main core and the primary cores down, the heat exchangers basically, and then comes back up this way, comes back into the turbine section of the air cycle machine, gets expanded rapidly, gets really cold. As it's coming through this section, we dump in some warm air coming from the temperature control valve, mix it in with that cold air, and by the time we get to the mixing chamber, the air is at the appropriate temperature. Pretty simple. That's how it works. In fact, to some extent, that's the way the preconditioned air underneath the jetway works. When we park at the gate, we don't necessarily want to run our packs. We don't want to run the APU. So they'll actually hook preconditioned air up to the aircraft in the big yellow tubes, about 12 inches in diameter, and it'll dump air, preconditioned air, right into the mixing manifold, bypassing the entire pack. And those units underneath that jetway actually operate very much on the same principle of compressing air and expanding it rapidly so that it cools down, and they can control the temperature doing that. So that's how that works, and moving on. Okay, so now moving along to the mixing chamber. We've covered this information just a little bit in the previous slides. We'll review it one more time just to drive the point home. Both packs normally supply air to the mixing chamber. The conditioned air entering the forward end of the mixing chamber is supplied by the left pack, and the conditioned air entering the aft end of the mixing chamber is supplied by the right pack. Since the forward section of the mixing chamber supplies air to the flight deck, it is considered that the left pack controls the temperature of the flight deck. Since the midsection of the mixing chamber supplies air to the passenger cabin, it is considered that the right pack controls the temperature of the cabin. Recirc fans, we've talked about those a little bit. I'll just read, and maybe it'll be a little review, maybe again driving the point home. As conditioned air from the mixing manifold is ducted into the flight deck passenger cabin, it is removed. With all the doors and windows closed, the conditioned air flows to below the aircraft flooring and is ducted back to the mixing manifold and or modulated out the pressure outflow valve. The recirc fans assist in moving the air through the conditioned air ducting. And important, as we talked about before, if the cargo air valve is not open, there would be no air going to the cargo compartment. We call this the puppy snuffer. And if you are carrying live animals in the cargo compartment, you must have this valve open to keep the animals from freezing on long flights at high altitudes. Let's talk about the air conditioning controls, where they're at in the flight deck. Air conditioning is controlled automatically and or manually by a switch position on the overhead air conditioning panel. How the air conditioning panel system is performing can be viewed by selecting the Environmental Control System, the ECS, synoptics page located, the synoptic page button, locate the synoptic page selector located on the selector. So let's just take a look at what we're doing here. I'm going to go ahead and zoom in a little bit here on this. All right, so we can see the overhead panel up here, and this is the section where the air conditioning panel is located. The air conditioning panel, I'm going to move my face over here. There we go. That works really well. The air conditioning panel looks like this. This is an exploded view or enlarged view of this panel. To turn the packs on, we would select this button and this button, and you'll see left and right. So we're actually opening up that valve when we push this button that allows bleed air to go into the packs. So we push that button, lights up, and then the packs are operating. We talked about the recirc fan. This is where the recirc fan switch is. If that is off, it's in the up position when it's off. When it's on, it's in the down position. Just the opposite of your light switches on the walls in your house. Don't know why, but think of it this way. The overhead panel sets at an angle over the top of your head. So when you flip the switches forward, that's into the on position. When you flip them to the aft position, the switches are then in the off position. That kind of makes sense to me if I think about it. When I first got on these airplanes, I was constantly flipping these switches in the wrong direction because I was used to a basic household light switch. So keep in mind, on is forward, off is aft. So in this case, it is in the on position. And then we have the ram air switch over here. We can open that up. We can actually dump air out of the aircraft pretty quickly by turning the ram air on. For example, if we had a fire or smoke in the cockpit, we'd want to get rid of it. We could open that up, turn that on, and it would flush out the air in the cockpit. Not important, not that important for our discussion right now. So we've got the pack switches left and right. Open those valves up, get air going through it. These two knobs down here, that's what they represent. They're knobs, not buttons. We would turn them to the right or left. This is, see where it says cockpit right here. And it says cabin right here. So we know that this particular knob controls the temperature valve on the left pack. This one is on the left pack, and then this one's on the right pack. All right. So let's take a breather right now. I've got to come right back here. Apparently I have a phone call coming in. So I'm just going to pause for a second. I'll be right back with you. Okay, guess what, folks? I'm back. That was a short phone call. They didn't want to talk to me, so I can get back to my job here. So these two black buttons right here in the middle, if you select those buttons to the lit position, you are going to turn the system from auto to manual. If you turn it from auto to manual, you'll have to operate the a valve using a toggle switch right here on each side. And if you remember what that toggle switch operates, I'll just show you. Let me go back for a second. Get out of this view. Let me go back a slide or two. Okay, this is a good slide to look at. Those toggle switches actually control the position of this particular valve. So if you're in manual, you're actually controlling how much bleed air you're allowing to come through this valve. So if you open it up all the way, you're going to get a lot of bleed air into the valve, mixing in with the cold air coming out of the turbine side of the air cycle machine. So it's going to warm the air up quite a bit. If you toggle it to the closed position, that valve, being the temperature control valve, is going to close all the way, and now the air is going to be somewhat cold. So now, if that makes sense to you, hopefully that is what you understand that this switch here is doing, those little toggle switches. So hot and cold for each of the two packs. Okay, this knob here, when you have these buttons selected to the auto position, these knobs here, of course, when you turn them right or left to cold or hot, modulate that same valve, only the computer takes it over, and it's in the automatic mode. So I hope that makes sense to you. But this is the air conditioning panel. It's over on the first officer's side. Generally, the captain will say, all the switches on this panel are his, except for this panel, and he puts you in charge of that, because what's going to happen is you will never get the temperature correct, and the flight attendant will be dinging you on the intercom system saying, hey, I'm too cold, or hey, I'm too hot, and you'll be chasing the temperature all over the cockpit, and the captain's just going to sit there and snicker at you, because he too was once a first officer, and what you like as a temperature is not what anybody else is going to like. What's nice about it is you do have control of the temperature in the cockpit, and you can set that anywhere you want. This is the synoptic page, the environmental control system. It shows you, in this case, you see the green boxes over here. This screen, by the way, happens to be right here in the flight deck. And that screen is, you can select different views of different systems down here, where you can select which synoptic page you want to look at. In this case, they have the ECS synoptic page pulled up. They're looking at this, and what we can see here is that pack number 2, circled in green or outlined in green, is operating. Same thing with pack number 1. And we're showing here where the pressure, the pneumatic pressure being supplied by engine number 1 is producing 44 psi in the ductwork and pushing air up through the pack. On the number 2 side, again, it's showing 44 pounds of pounds per square inch in this duct, and we have the isolation valve being closed, and now the pressure is going up through pack number 2. Then we have the selected temperature. So we would use, for example, here for operating the cockpit side, we can operate it to the colder or hotter positions. If we select 21 degrees, we can turn this knob till we see 21. Then the temperature will gradually increase or decrease to try to match up and have these two temperatures match. And as we can see here, the supply side coming up through from the manifold is showing also 21 degrees in that duct. So you got a lot of information there. And then, of course, we've got some more information down here we won't deal with at this point in time. Okay. Preconditioned ground air. Well, what is that all about? That's the air conditioning, preconditioned air that we supply to the manifold, mixing manifold. This is not like air coming, this is sort of like air coming out of the packs. It can bypass the packs. This is air that is being developed from outside externally of the aircraft while it's parked at the gate. This is that air conditioning unit hanging underneath the jet bridge, or maybe it's a ground power card of some sort, providing preconditioned air directly to the mixing manifold. So in that regard, we can turn the packs, the left and right pack, both off, and we don't need to be using bleed air, so we can have the APU off. We don't have to have the engines running. We can just basically dump cold air or preconditioned air directly into the manifold at this point. And you'll notice that we have a port on the side of the aircraft right here. That's what this represents. We're pushing preconditioned air right into the manifold. And then from the manifold, that preconditioned air goes into the cockpit in the normal manner from the manifold, mixing manifold. So this is considered low pressure air. It's preconditioned air used to control the cabin and flight deck environment when the aircraft is on the ground and the pack system is not being used. Low pressure preconditioned air is provided directly into the mixing manifold from a port located on the outside of the aircraft. Preconditioned air is supplied to the mixing manifold, is supplied directly to the cabin and the flight deck. There is no method of control. We can't turn the little knobs up on the air conditioning panel. It's out of our control at this point. The ground control is the ones controlling that. Now, if we go outside, there usually is some sort of temperature control on the unit providing this air. But trust me, you as the pilot do not want to get involved in that system. If it breaks, you're going to get blamed. So keep your hands off. Let the ground control get in trouble. Ground crew get in trouble over that. So that's it. That's all I've got to tell you about the air conditioning system. Again, go to your air conditioning module in the AeroSim program, review it, get through it, answer all the questions at the end. And then once you have completed the module, go back and sync, and then move on to Hangar Talk, where you can ask a very intelligent and enlightened questions about the air conditioning system. Again, I love my job. Glad to be here. Hope I can make a difference.